Hello once again, this is Skip, Victor Echo 6 Bravo Golf Tango. I'm back at it again after a bit of a delay. We're going to show you what we've been doing with this crazy offset dish frame I've been working on. If you watched my part 6 of this experiment, you'll see how I had this dish set up outside and discovered just how bad the mount was. The aluminum frame wasn't going to work, and it was just all around too darn floppy to use, but good enough at the time for some testing. The aluminum was okay for the prime feed dish, but for this offset dish, something had to be changed. The old TVRO actuator wasn't any good either, so back to the shop, and it was the winter of 2024, and we're back at it. Not only did I want to get rid of the aluminum frame, but I also wanted to use this gearbox I had, this double worm 500-to-1 ratio gearbox, which I've had laying around and using for different things. I had thought of getting another slew gear, but I figured if I could get this gearbox mounted on a frame and have it directly driven to the elevation axis of the new frame for the dish, you should be able to lift it. Of course, this meant new mountings, new bearings, shaft, etc., etc., and all the other engineering and configuring to get it to work in this method. So out came the plasma cutter one more time. I had to build we'll call it side brackets for the new bearings to sit on. I had to assemble this all on top of the vertical mast because this frame bolts to it, and I had to cut the old bearing ends off and shrink everything in a bit so things are loose, and I wanted to keep things in the same fashion so it bolt back on here again. So it was a bit of a clamping nightmare to keep everything in place while I tacked it together. So next on the agenda was to replace the aluminum frame. I still have some 2-inch steel angle iron from other projects, and the price of steel these days, I figured I might as well use it up, so I proceeded in making a frame identical to what the aluminum one was. The same with the, what do I want to call it, the side rail, or the pieces of channel iron anyways that the axis swivels on. It was aluminum before, and now I've milled it out of some steel channel iron just for the strength. This is where the difference begins. The aluminum frame was just bolted to pillow block bearings and swiveled on there because it was being moved by an actuator arm. This now has to be connected through a keyed shaft into the gearbox, and I didn't want to weld these keyed hubs to the channel iron because chance of getting the keyway all lined up for all three items is going to be pretty slim. I could probably weld it in place, but then again I have to slide this this keyed shaft all the way through all three items, and that'll be a little tight. So again, with the plasma cutter, I cut out some, we'll call them ears or tabs with a 1/4-inch steel and welded them to these hubs. This way, after I get the frame in place, I can slide these eared tabbed hubs, whatever you want to call them, over the shaft onto the frame, put the little key in place, then tighten down the bolts. I find that just because of misalignment and the way they weld made the metal warp a little bit slightly, when I tighten down the bolts, it makes everything real nice and tight, so it's kind of a bargain all the way around. Just to prevent any sideways movement, I cut the shaft to length. I threaded a hole in each end and then laid up these caps that go on the end and bolt on tight, and it sucks everything in snug against the bearings. Of course, for every action there's a reaction. When I suck these in tight, the 1/4-inch plate that the bearings are bolted onto tended to be pulled in, so I had to put some cross struts in there to keep everything solid so everything could go tight without any movement. After all that, I put some cross members from the channel iron up to the top and bottom of the frame out of some, I think it was 1-inch angle iron, just to, reinforcement. Remember, the whole idea of this rebuild was to strengthen things, so no sense going halfways with it now. Last but not least is the counterweight arms. Still needed them, so drilled 3 holes into the chunks of square tubing I used from before. Then with 3 large bolts, these bolted to the channel iron frames that are on the steel dish, or steel frame now, I mean. And the counterweights will slide over the ends of these just like they did before, with no problem adjusting them for, like sliding back and forth. And the very last thing that had to be done was weld on these tabs that the aluminum frame on the dish will hook to. And then at the top, little cross members or cross pieces of steel go across with a hole in it. And this is where the adjustment rods for the, we'll say the offset angle for the dish adjust through. All made of 1/4 inch steel and welded on. All done and ready to go. So finally the fun part begins. I didn't want to use the support stand. I wanted this thing as low to the floor as possible so I could elevate this thing. So I took the vertical mast and welded it to the end of the welding table, slid it all over to where the overhead crane was on my roof, and proceeded to put things together. I was hoping it would clear the roof. So here we go. The first thing to do is get the motor assembly on top of that vertical mast mount. I could lift it with using a ladder, but geez, the crane's here. Why pull a muscle or strain my brain? Might as well use the winch. Besides, this is kind of a good dry run. When I assemble this thing again outside, I'll be using the crane on the Jeep. So this way, things are going to tell me if it's going to fit or not. I might as well run into snags or problems now instead of later. Get the 4 bolts in place, and it'll tell me if it's going to fit. It should. It was drilled out. I changed things up to a slightly bigger size bolts than what I had before. I figured with all the extra weight, not that the bolts would break, but I just feel safer that way. I like overdoing things. So far, so good. Next was the 2-inch angle iron frame. Again, it's not heavy, but it's darn awkward, and plus I have to wiggle this thing over the end of the shaft of the motor, and it could be a little wobbly up there on top of a ladder, so the overhead crane I got in the garage here will prove very handy once more. So this is the first time I tried putting this frame onto the motor shaft assembly after I put those 4 cross members, those 4 pieces of angle iron from the channel iron up to the top corners and the bottom corners of the frame. I discovered it didn't want to go. It took a bit of wiggling, but I did figure it out later. But what did I say earlier about doing a test run on things? I found if I slid the keyed shaft to the gearbox farther over to one side, then I could wiggle the frame into it. It was a little bit tricky, but it goes. So we're off to the races one more time. Next was the specially modified little keyed hub assembly thingy bobs that I built that goes onto the shaft and bolts to the channel iron frame. Next was the 2-inch square tubing for the counterweight assembly. Easy to put on, just 3 bolts and slide them in place, bolt them down tight. Now with those hubs in place, I rotate the motor and get the keyways lined up so I can slip in the keys themselves into the slots. The slots all lined up, I tap in the keys, I guess we'll call them, the square keys, and then put on the special caps I built to thread on the end and clamp everything tight. Tighten on the bolts on the flanges off the hubs, and she's good to go. So with all that put together, I guess the thing left now is run it up and down with the motor and see how things go. It seems fairly rigid. There is actually quite a bit of play in the gearbox, but what I was seeing here was the weight of the counterweight arms was actually keeping it up tight against one end of the place. So this is what I kind of expected. This is what I had planned. So I'm just going to run the motor up and down here and check it out for clearance, make sure nothing's binding or hitting, and make sure everything's A-OK before we mount the dish. I would never be running the dish this high in elevation, but yeah, run it up there, see how it goes. I stop it here. I want to just find this play in the gearbox. I want to just see how much there is and see if it's going to be a concern. It does move quite a bit, but like I said, I hope to have the weight all against it, and it shouldn't be a bother. So finally, it was time to get the dish up onto the frame and get around to the final testing. I show it here hanging on the winch, and I didn't take any pictures. I mounted the aluminum framework that goes on the dish itself that bolts to the new steel stuff. So that was the next step. So up it goes on the winch. This is actually the second time. I had it up once already and discovered I had the metal steel tabs, the new tabs on the frame, 1/8 of an inch too in or close to each other, and the aluminum part on the dish wouldn't fit in between, so I had to spread them out ever so slightly to get it to fit. It finally went. It's a snug fit, but they do slide in there, so it's good enough. It's just for adjusting the angle of the dish, and not like it has to move a lot. Being rather snug now, though, it's not as easy to get the holes lined up to get the bolts put in. Bolt number 1. And bolt number 2, so she's clamped onto the frame. As I've said before in other videos and earlier, maybe this swivel point is just to get the dish angle, the offset angle set. Once it's done, it'll be clamped tight. Next, I installed the angle adjust arms, we'll call them. It's what holds the dish to the top part of the frame, where the lower is on those earlier bolts I stuck in. So just set it at an angle, tighten down the bolts, and on we go. At this point, I wanted to check to see how solid everything was. I got this thing welded to the end of my metal welding table, which should be plenty of ballast to hold it. I just want to make sure this thing wasn't going to tip over if I started moving the dish. So I released the winch quite loose and then went to the end of the welding table and give it a good shake just to see what was going to happen. So I haven't got the counterweights on this yet, so I thought I'd fire up the motors and just see if it would pull the dish up. Quite a bit of weight out there, and to my surprise it did, but with a little bit of current draw though, got to say, on the motor. So I put the counterweights on and hooked to my pulse width modulation control system and raised the dish, and to my surprise it was going to clear the crane on the roof, so I had to disconnect it. So I took the crane assembly off, and I had to slide the table back a little bit. It cleared the winch frame, and now it's just hitting the roof. So I was hoping I could go all the way up, but I couldn't. So about 40 degrees, enough to test it anyways. So I continued on moving the dish back and forth, up and down I should say, and this is what I was afraid it might happen. There was quite a bit of bounce on the dish, and especially I was going high speed and I stopped, it would sit there and just bounce and oscillate forever. Bounce, bounce, bounce. But I had a bit of a cunning plan. I was kind of expecting this. So what I needed is some kind of friction device to dampen the movement of the dish as it tried to bounce. And this is what I started with. I'm not sure what this material is. It's kind of a slippery plastic. It's Teflon or something like that. But anyways, I got a long old chunk of it here. And I clamped it to the dish and just lightly clamped it to the mast. Clamp kept wanting to fall off, but it showed me that that's all it took, was just a little bit of friction to keep the dish from bouncing. So I had a good idea what to do. So I went through my collection of material again and found some 1/2-inch conduit, and I think it's the other pipe. There's a 1.5-inch piece of conduit. I took that plastic and cut it up into square pieces. I drilled out the holes so that they would just fit just snug over the 1/2-inch conduit, and then took 4 or 5 of these pieces and assembled them onto a piece of conduit, then onto this bolt, which was going to clamp all the plastic pieces tightly together. I then cut the larger pipe to a certain length. This is going to be part of the dampening device, and the trick is here the square plastic pieces have to fit into a round pipe, and this is where the lathe comes in. So this is how you make a square peg fit in a round hole. Lots of plastic shavings to clean up also. So I put it all together. I used some old mounting hardware off an old TVRO actuator arm. The 1/2-inch conduit slides through the plastic pipe and connects to the dish and gives it enough friction to dampen any bounce that's created when the dish motor stops and starts. So here's proof in the pudding. This is before the dampener is put on. And this is after with the dampener installed. So I moved it up and down and tried it at various speeds to see if there's any real serious restriction, but seems good. It seems to work very well. You can really notice it here looking at the end of the feed mount that a little more travel. Then this is what it's like with the dampener installed. It makes quite a difference. So this just about wraps it up. I continued testing, mainly the elevation motor up and down to make sure it kept working the way I want it to. I'm quite pleased with the dampening system, that little plastic rod through the holes deal. I'm quite amazed how well that works. Probably going to have to weatherproof that. I imagine if it got rain on it or something, it would slide a lot faster, a lot easier. Dirt also, so there'll be a weather boot going over that. But all in all, it seems to be working. But the only thing I got left to do now is tear it back apart again, maybe paint it. But the next step is I've got to get all the electronics mounted on this thing. Got to figure out how I'm going to put the positioning encoders. I had some ideas, but after doing this test, I can see where I'm going to run into some snags. So there's lots to figure out yet. We're not at the end of it all yet. Anyways, it's coming along, one step at a time. So once again, thanks for watching. This is the latest on this part of the project, and we'll get back to you with more. So 73 from Skip, Victor Echo 6 Bravo Golf Tango.